So today we we are going to uh, look at the Java collections, which we had promised in last episodes that we'll work on a linked hash map. We worked on hash map and tree map. Just to recollect, these were the examples we did, and we observed that if we use the hash map, it's not sorted, and that's why we use tree map and we did the collections of reverse order. So after tree map, uh, we're going to work on today linked hash map. So let's try to write an example with linked hash map. Uh, the linked hash map. So I think the volume was low. Let me repeat what I said. So in the last episodes, uh, so far let's start from the beginning. So this my total episodes talks about all the collections, and in my videos I have worked on simple examples for all collections, and we finished this series uh, of the collections, and then I came back to this one where I started with map, and then we used a tree map and we use a sorted map. We tried to use the hash map also. Now we'll try to use the linked hash map and the hash table as an examples today. So a simple way, let's try with the hash table, and then we'll go with the linked hash map. So let me open an example here, a Java class, and we'll name this as hash map example, hash map example, map example, and then since we are writing this class, it says type name is not valid. A Java type must not start or end with a blank, so there is a blank in the beginning. Where is the blank? I don't see a blank. Then what methods would you like? So let's include public static void main, and then type name is not valid. A Java type must not end start with a blank. Okay, hash map example. Then it's okay. I think there is some issue. I'm not going to waste time on why this is not coming. Let's do one thing. Let's make a copy of this test Java. Copy, paste, test2. Let's open this. Let's rename this class to hash table example. Hash table example. And then when you rename this to hash table example.java, now we have we need to use the hash map hash table here. So when you see this diagram, hash map, it's again what? It's a concrete class. So maybe I can use the interface on my left side, right? Map, my map equals new hash map. JSH and EMR capital, JSH, MAP, and then I'm going to close this quotes. Then we don't want any thread details here. Then let's do a quick fix, import hash map. Then what? What is this? Import map. Okay, so far so good. Like in our previous examples, uh, we are trying to, let's rename this as hash table example. This will be a better approach. Now I declared a hash map. Now let's see what is available here. Can I add something in a hash map? It's a key value pair, so I'm going to say my map dot one, right? My map dot what is this? So it says put object value key, right? This is the one I'm going to use. And then both I am putting as objects, I'm not declaring them. So I'm going to say RAMA, Rama, and I'm going to close this with a semicolon. Then I'm going to say Sita and Lakshmana. Key number 2. And this is Lakshmana. Let's put Sita and then Lakshmana. Sita and then Lakshmana. 3. And Lakshmana. Lakshmana. Okay, I have put some values inside this as key value pairs. How do I print them? First of all, I need to iterate through a map, and then I need to print the values. Let's see if map is having some way to have a iterator. Dot what is this? For each is there, entry set is there, which gives me a set. Merge, notify, put all, remove. It has a size. I can put a for loop and a size, right? Or I can use for each.
Recording in progress.
So we had we should get the iterator now. Let's see what methods are available. My map dot entry set dot what else is there in entry set? Dot iterator, right? you have an iterator. So let's say iterator, iterator, my iterator is equal to, so I got an iterator here. Since I'm using object, I think I can,
Recording in progress.
so I can use an iterator now. Using this iterator, can I iterate? Let's see. While, let's put a while loop. I can put a for or while, doesn't make any difference. My iterator dot as next. Println dot, it says just next. So let's the next object, and then I'll say elements, and then this one. What does this say is that what do you expect now? I just randomly picked up a hash table example. Then I saw this collections. I saw the hash map. Since I knew that it is using the interface map, I used on the left hand side an interface. And I'm using strings, but strings are objects, so I have not declared, you know, the generic. It is still raw, right? References are raw. What does this print? Let's see. Okay, now it is what it is doing is that it is printing the key value pair, right? So let's print it better. Okay, it's printing the key as 1 and its value as Rama, 2 as the key and Sita as the value, 3 as the key, Lakshmana as the value. But remember, this is already in sorted order. It's maintaining the order. So this is a very simple example of hash map, but I did say we will talk about the linked hash map also, right? What did we learn from this hash map is that hash map is also another map which stores key values, but we were talking about hash table, not hash map. But purposely I took hash map and then wrote an example. Now let's try with the hash table. Is it the similar thing? Let's try. Will this work? Hash table. Okay. So I change everything. I just replaced hash map by hash table. This is not needed. Let's remove this. And then you see that I have hash table example now. Will it work? Let's try. Yes, it's exactly working. So this is hash table. Let's go back to our collections. Now what remains is the linked hash map. So how does a linked hash map work? Let's try. Let's, make another example. Uh, Copy, paste. Let's open this. Let's rename this to linked hash table example. Example. Rename this. And then what I'm going to do is that, can I replace here just by linked hash map? Let's revisit our diagram here. So just like hash table, I just replace this with linked hash map. So all I need to say is linked hash map, right? So I'm going to import this, right? Save it and run it. Will it work? Yes, it worked. But the way we have studied this collections, these two collections, we don't know. We are going very blind. We don't know whether this is, you know, uh, the right way we need to use these collections. So when do we use a hash table and when to use a linked hash map? That is what we need to discuss. The first thing. Second thing is, in this collections, I was talking about the thread examples. Uh, we did talk about, how to. If you see some of my other episodes, I'm talking about thread, the concepts of thread and all. Then I talked about the parallel processing using threads. Now the first thing is that uh, when we store uh, name value pairs inside these structures, we also operate on these structures using some elements like iterator, right? Now we were also talking about how do we synchronize operations. So, and why do we synchronize? The basic reason behind synchronization is no two people should work and you know uh, make the data corrupt. Like for example, I want to fill the fourth key here. I'll say in the fourth key, I'll say Hanumana. Fourth is Hanumana. But what is that, this particular thread is putting Hanumana. So added the fourth key here and put Hanumana here. Now, when I give this map to somebody in some other program, like I say, this is my linked hash table example, and I'm going to remove this public static void main and give this class to somebody else. And what on the same class, two threads operate. Somebody wants to add the fifth key. So fifth key may be Bharata, right? They want to add like this fifth key Bharata. But when you're adding at the same time, the iterator is iterating through this. Uh, Iterator can do changes. Is it possible when you're operating here? What does this remove do? It removes an element, and you know let's remove this. So we iterator is at the same time removing something, and we are also adding something. How do we make sure that the addition and removal does not happen at the same time? So that's where the synchronization comes in picture. And in my next episode, I'm going to talk about the inherent quality of these collections. That is, are these collections thread safe to work on? Now, if I go through this, if I just say linked hash map, I just googled for this linked hash map. What what the API says for this? Why we have a linked hash map when hash map can do our job or hash table can do our job? It says this implementation is not synchronized. If multiple threads access a linked hash map concurrently, it is one of the thread modifies the map structurally, it must be synchronized externally. This is typically accomplished by synchronizing on some object that naturally encapsulates the map. If no such object exists, the map should be wrapped using collections.synchronize map. So this is where we need to start thinking about how we do synchronization. But what is the speciality of linked hash map? Hash table and linked list implementation of map interface. So this is a linked list. It's not just a table, it's a linked list. Hash table and list implementation for map and will predictable iteration order. It is both. It is a linked list as well as hash table, and it has a fixed iteration order. How does it differ from hash map? The limitation differs from hash map in that it maintains a doubly linked list running through all of its entries. So this linked hash map link has a doubly linked list. This linked list defines the iteration ordering, which is normally the order in which keys are inserted into map insertion order. Note that insertion order is not affected if a key is reinserted into map, right? A key is reinserted map using em.put key is invoked em.contains key would return true immediately prior to invocation. Very important thing is that we learned that if you want to use this predictable iteration order, then you should use linked hash map because it is linked. It's doubly linked list. But we just saw the concepts. What else it is having? Linked hash map has a special constructor, a special let me expand the, you know, it's it's not okay. Now let's see. So we saw that hash map, just repeating because I increased the font. Hash table and linked list implementation of map interface with predictable iteration order. Now we are going to a special constructor. A special constructor is provided to create a linked hash map whose order of iteration is in the order in which entries were last accessed from literally from least recently accessed to most recently. So we are talking about order of iteration. How is the order of iteration? Order of iteration is the order in which entries were last accessed from least recently accessed to most recently accessed. This kind of map is well suited to building least recently used caches. So here we go. Now we are talking about how we can use linked hash map to build caches. What is a cache? That's the question which comes to us. Cache is not our CESH cache. It is a cache where you know a value which is frequently used you know uh, we store it so that it is easily accessible. We store it in the working memory. Why do we need caches? Because we will save on the IOs, inputs and outputs. That's why we need caches. So this is what linked list, hash linked hash map is talking about. It has a special constructor. We'll go more deep about linked hash map in the next episode. But for now, in this episode, I'm going to stop here. If you like this, please hit the subscribe button. And in the next episode, we'll discuss more about the LRU caches. But quickly to summarize, we went through this. We went through hash table, hash map, then we used linked hash map. We also discussed about what is synchronization. Uh, and then I just wanted to show that iterator also can work on simultaneously, right? So I added remove, and then you see Hanumana is there, right? So I can have one more iterator. Sorry. Let me finish this and then I'll end the episode. I'll say my iterator 1. Okay. And then what I will say is that my map 1, sorry, my map dot entry set. Would it allow? What does it complain? It says iterator 1 cannot be resolved. What's a quick fix? Okay, it's not allowing me to create another iterator, which is fine. Now when I remove, uh, what happens? Let's see if it gives me a problem. I'll try to print when everything is removed. What would you expect here? Uh, my iterator dot next. What is this? System or dot println my iterator dot next. I'm trying to print something which is not existing.
Recording in progress.
So what I did is that I just put the system out dot println here. We are removing each element. What do you expect? After say removing the last element, that is Hanumana, I remove this and then I try to print something. Would it print? Let's see. You need to run this as a Java application, proceed. Okay. It says element 2 is equal to Sita exception in thread main. Then printed Lakshmana, and when it tried to print Hanumana, it says that no such element. So you see two issues here. That's what we are going to talk about, is that in our next episode is how to use synchronization to make collections safe. This is still not safe because you know we are iterating at the same time we are removing something, and when we remove we are landing into an exception. How do we avoid this kind of situation? That's what we'll discuss in our next episode. Thank you. If you like my video, please subscribe, hit the subscribe button. Let's meet in our next episode. Happy Java coding. Thank you all.